I would say one of the biggest differences between differential calculus and integral calculus is that with the rules that we get from differential calculus, as long as a function is relatively, continuous, we can find a derivative of it. For example, if I asked you to differentiate e to the 3x divided by x, combinations of the rules for exponentials, the quotient rule, the chain rule, we could make it happen with very little difficulty. However, all I got to do is ask for an antiderivative, and then it all gets thrown out the window. So what we're going to do instead is find a power series representation of this integral, as it were. Now, the way that I'm going to do so is start by creating the power series representation of e to the 3x. Then I'm going to divide through by x, and then we're going to integrate. So first things first. The power series representation of e to the x, also known as the Maclaurin series, looks like this. Now, if I replace the x's with a 3x, I will have the Maclaurin series or power series representation of this function. Now, in anticipation of the things that we're about to do, though, I'm going to make an alteration to this, and that alteration is going to be, I'm going to call this 3 to the n divided by n factorial times x raised to the n power. Next, I'm going to divide through by x. Now, all that that's going to do is reduce the power of x by 1. So we'll get an x to the n minus 1. Now, to be clear though, that means that the first term in our series is no longer going to be a positive power of x. The first term in our series is going to be, well, actually it might make more sense if we started back here. So plugging in n equals 0, we would have 3 to the 0 divided by 0 factorial times x to the 0. That is 1. For n equals 1, this will be 3 to the 1 over 1 factorial times x to the 1, so 3x. Then we'll see a 9 halves x squared, then a 27 over 6 x cubed, etc., etc. What I'm saying is we just divided through by x, which means that the first term is going to be 1 over x. The second term is going to be 3. Third term, 9 halves x, followed by 27/6 x squared. Every single one of these terms can be integrated using the power rule except for the first term. So when we integrate, we're going to have to pop off that first term as something that's separate. So first off, constant of integration plus, this will become the natural log of x, or natural log of absolute value of x, plus, then we can integrate the rest of these terms according to the power rule. Now essentially what we did is we took away the n equals 0 term, and the rest of these, starting at n equals 1, can be integrated using the power rule, which means that the power of x will go up by 1, back to x to the nth power, and we divide by the new power. So we'll get n times n factorial. This would be the power series representation of this indefinite integral that without the use of power series would have been impossible.